Hello everyone. Welcome to Step 421 class. Today we'll study regression estimation. Last week we have studied the ratio estimation. Ratio estimation is probably the simplest method of incorporating auxiliary information in the estimation stage. However, it has several limitations. First, it is not location invariant in the sense that if we if we add some constant to y, the ratio estimator, so the ratio estimator using CI is what? R times, okay, let's do it different way. So R times C bar, right? And then C bar is Y bar plus C. So that is R Y bar plus R times C. So that is Y bar ratio plus R times C. So that is different from Y bar R plus C. So the ratio estimator of the additive transformation is not equal to the additive transformation of the ratio estimator. So that's one limitation. Second point is that the ratio estimator is not always better than the simple mean estimator. It is better only if the correlation between x and y is high enough. So if it's not the case, then it doesn't necessarily good. The third one is that it's not really applicable for multivariate auxiliary variables. The framework for regression estimator is very similar to the ratio estimation. We'll assume simple random sampling of size n from a finite population of size capital N. The auxiliary information xi observed in the sample and the population total or population mean of x are available from external source. From an external source. The main idea for regression estimation is to adjust the sample mean y bar based on the difference. So in the ratio estimator, we adjust it by the ratio, right? So we apply it in a multiplicative way, but in the regression estimator, we apply it in a additive way. To motivate the regression estimation, consider a linear regression model, and B0, B1 is unknown parameter, and E is the error term, the zero mean. Okay, if xi and yi are observed throughout the population, then the slope and intercept can be computed by this formula. Okay, if you look at this carefully, then you can rewrite it as something like this. So you can see that this is your regression model, right? So this is your regression model, and now you have these numbers from here, right? And so if you so this relationship basically says that if you plug in x bar here to the population mean, this becomes y by u, right? Now, so that gives another way of obtaining population mean of y. But the problem is that we don't know B0 and B1 in practice, because we only observe y in the sample. So then we can simply use the sample to estimate the regression coefficient, and then plug in y by u from population. Okay, so that is called the regression estimator. Okay, now the formal definition of the regression estimator is this. Okay, so that is basically a prediction of y at x equal x by u using regression model. And this is the sample version estimator of the regression coefficient. And if you write this one to here, okay, plug in, and then becomes y bar plus b hat 1 x bar u minus x bar, right? So that's this one. Okay, then this is unbiased estimator, right? This is the usual estimator on the simple number sampling, and so this is adjustment term. Okay, so the regression estimator makes an additive adjustment to the sample mean of y bar, and this is the adjustment term to the sample. Okay, so here's the some example. The right side shows a plot of sample element. So we have 30 samples from normal y equal x equal normal mean 2 and variance equal 2, and so with this error term, then y given x is normal normal 4 plus 2 1, right? And so the population mean of x bar in this case is 2. So the red line is the population mean, and the sample mean from this particular sample of size 30, we have 2.14. So sample mean is not exactly equal to the population mean because of the randomness, right? So randomness of the sampling. Okay, so that is the sample mean here. Okay, and the fitted regression. So the regression using the sample, we obtain this one. So y hat will be 3.88 plus 2.028, okay, x. Okay. So what is the value of this one? X equal x bar. So for the sample mean, 3.88 plus 2.028 x bar is 2.14, right? So that then you can obtain this one, 3.3. Why? Because the p hat 0 is y bar minus p hat 1 x bar, right? So this is 3.88, this is 2.028, and this is 2.14. So then you can obtain this guy, y bar. So that's how you get this one. And so that means if you plug here, and then you have something like this, right? So that is a y bar. Okay. And the regression estimator is a prediction at the population mean of x. So you obtain. So if you plug in the population mean here, this is the regression model. This is 7.9 9th. So you end up getting, so that is this one, regression estimator. Okay, so that is the basic idea of the regression estimator.